Now we're going to look at the inverse sine or inverse secant, cosecant, and cotangent. And there isn't a button for inverse secant, cosecant, and cotangent, so I'll show you how to deal with that in your calculator as well. So the inverse of cosecant, the middle one, has a domain of basically you cannot equal any value between -1 and 1, so anything in the middle here, okay? And the range is from negative pi over 2 to pi over 2. So it's shown here, which basically tells us that our answers or our angle answers are given to us from quadrants 4 and quadrants 1, okay? That's where we're going to draw our triangle as well. In secant, we have a really similar setup. We can't equal values that are in between -1 and 1 for the domain. And for the range, the values are always given to us between 0 and pi. So that would be represented on the unit circle. That would be from quadrant 1 to quadrant 2. Cotangent is secant and cosecant have the same range as sine and cosine. So secant has the same range as cosine, and cosecant has the same range as sine. Okay. Cotangent does not have the same range, is not the range of tangent. This is one that's a little different. We notice that the range is between quadrants 1 and 2, so it actually has the same range as cosine. So when we solve, we're gonna use, we should put cosine inverse, sine inverse, tangent inverse. Okay, so has the same range as cosine inverse, so we're actually going to use cosine inverse to solve our cotangent angles. All right, so another way to write our inverse trig is basically y is theta. We're solving for an angle, and then we're taking the secant inverse of x. And we just want to remember that we are solving for an angle, and this is the ratio of sides using the r over the x length of our triangle. Okay, so another way to write this equation would be theta is equal to its reciprocal, cosine inverse, of, instead of x, you would use the reciprocal. Okay. Cosecant, we can write as theta is equal to the cosecant inverse of x, which we are going to remember that the input is the ratio of sides. So the ratio of sides for cosecant is r over y, since it's the reciprocal of sine, and the angle is what we're solving for. So another way we can write this, the reciprocal of cosecant is cosine, oops, I did that wrong, is sine inverse of y over r, okay, oh, of 1 over x. So we're reciprocating the value inside the parentheses. Okay, did I do this right? Yes, okay. So cotangent, we use cosine inverse of the ratio. I'm just going to put ratio because the side lengths change because we have to draw out the triangle and stuff. So What we're going to do is instead, theta does not equal tangent inverse of 1 over x. Okay, remember that? We don't use that one. We use cosine inverse because the range is the same. So where we get the outputs or where we get our answers, the quadrants that we get our answers from are the same. Remember, the range for cosine inverse is quadrant 1 and quadrant 2. So we're going to use theta is equal to cosine inverse of 1 over our given ratio. Okay. All right. So let's go ahead and calculate these without using a calculator first. So first one is secant inverse of -2 over root 3. So I'm just going to evaluate this, and I'm going to write that this is the ratio, and I always write the side lengths that this is the r, the radius, over, since it's secant, it's the x length. So and what I'm solving for is an angle, in the first or second quadrant. So from 0 is less than or equal to theta, or is less than or equal to pi. And we know that because we can see that secant inverse's range is in the first and second quadrants. Okay, so it means that your calculator is going to give you back an answer from the first or the second quadrant. Okay, so when I set up my triangle, I'm only focusing on the first and the second quadrant. I look at my ratio. It is negative, so it's going to be in the second quadrant. So I'm going to draw my triangle in, and I am now going to, well, what I'm going to do now is go ahead and use the reciprocal. So cosine inverse of, instead of -2 over root 3, I'm going to write -√3 over 2, which is the reciprocal, and that will give me the same angle. Okay, so I'm going to set this up as -√3 over 2 is the x, 1 is the r, and then if I needed to solve for my third side, I could. Okay, well, I can. I know this is a 30, 60, 90 triangle, so I'd have a length of 1/2 for y, which means that the angle right here the reference angle is pi over 6. So my actual angle would be 5 pi over 6. Okay, from the in standard position, the initial side to the terminal side would give me an angle of 5 pi over 6. So theta, the angle that gives me this ratio, this cosine ratio, is 5 pi over 6. Okay, next, cosecant inverse of 2. So again, I'm going to label that this is my ratio, and it consists of the r length over the y length. And since it's cosecant inverse, I can go ahead and just use the sign. Oh, and this equals theta, which is going to be an angle. And I just go back up to my list, and I'm like, okay, cosecant inverse is between -pi/2 to pi/2. So -pi/2 is less than or equal to theta is less than or equal to pi/2. So basically in the fourth or the first quadrant. Since we're using cosecant inverse, I can go ahead and just set up my ratio as sine inverse of the reciprocal of 2, which is 1/2, and that's going to give me my angle. So now I have a ratio, instead of r over y, it's y over r, and I'm still solving for that same angle. I'm going to set up my triangles, so either in quadrant 1 or quadrant 4, and my ratio is positive. So sine is positive in the first quadrant, so I'm going to go ahead and use that, set up my triangle there, okay? The sine ratio is 1/2 is y, r is equal to 1, and then the x would equal √3/2. You don't have to really write the x, but I like to see that it's a 30, 60, 90 triangle and prove it to myself. So this angle, the reference angle and the angle are both pi/6, since that's across from, since the y length is 1/2, okay? So then I'd have my answer. The sine ratio, the angle that gives me a sine ratio, so the angle that gives me a sine ratio of 1/2 is pi/6. All right. Okay, we're going to move on and do a couple in our calculator, and then I'll come back and show you how to do the cotangent, okay? So in our calculator, we're going to, since there is no secant and cosecant inverse button, we have to write, we're going to round these to 2 decimal places too. I didn't write that. Okay, so anyway, we're going to rewrite these inverse trig expressions as in terms of sine and cosine, okay? So for secant, we rewrite this as its reciprocal, so cosine inverse. And when we do that, we reciprocate the ratio. This would be r over x. So we want to write our new ratio as x over r. So I put 1/3. The sign stays the same, just the ratio gets reciprocated. So I'm going to double check that I'm in radians mode. Okay. And then I'm going to use secant cosine 1/3. And that is, so theta is about equal to 1.23. All right, let's do another one. Cosecant. So we can rewrite that. Remember, this is the ratio of r over y, okay? And so cosecant inverse, I can use the reciprocal of sine inverse, and then I need to reciprocate the ratio. So now this new ratio would be y over r, okay? So in my calculator, I'm going to go ahead and type in sine inverse of -1/4, or -0.25 you could have used, is going to give me this angle. And just to reiterate, this angle comes from the first or the fourth quadrant, and since the ratio is negative, it's going to come from the fourth quadrant. So my y length would be -1/4 here, okay? So the angle that gives me this triangle is, in radians, is -0.25. It's about equal to. Okay. All right. You can't see the triangle, so I'm gonna go back. All right. So the angle that gives me the triangle with the y length of -1/4 and the r length of 1 is -0.25. Okay. Last one. Cosecant of inverse of -1/3. Remember, this is my ratio of r over y. So I'm going to use the sine inverse of -3/1 is equal to theta. Okay. Again, it's going to give me a triangle in the fourth quadrant because the ratio is negative, and cosecant inverse gives me an angle from the first or the fourth quadrant. Okay, so I go ahead and type that in. Bring this back. Sine inverse of -3. And what I get is a domain error. So what I noticed is that, well, what we know is theta is undefined. So what I noticed is that back at the top, I said that cosecant has a domain of negative infinity to negative 1 and 1 to infinity, which means that any value, I can't plug in any value between negative 1 and 1. So when I go back, I look and I see that my input is less than, it's between negative 1 and 1, which is illegal. It's not part of the domain. So we can't calculate that. Another thing I noticed is that sine here, sine has a domain of negative 1. All the values happen between negative 1 and 1, and so negative 3 is outside of sine's domain. Okay. All right, let's go back and look at our cotangent, how we solve cotangent. So we're going to go back and find the exact value of each expression without a calculator. Okay, so I have cotangent inverse of 1. This is where we have to set up our triangle and stuff. So I just remember that I always label the ratios. The ratio of cotangent is y. The ratio of cotangent is x over y, okay? And because it's the reciprocal of tangent. And what we're going to be solving for is an angle, but the angle is between 0 is less than or equal to theta, which is less than or equal to pi. So what that looks like is we end up with a triangle either, or an angle, either in the first or the second quadrant. The ratio is positive, so it's going to be in the first quadrant. So I'll go ahead and just sketch in a whatever triangle. And then I notice that the ratio is 1. So I am going to go ahead and start labeling my side lengths. The only triangle that I know that has a side length, a tangent of 1, or a cotangent of 1 would have equal side lengths, so root 2 over 2 and root 2 over 2. So if it's root 2 over 2 and root 2 over 2, then the third side I could solve for, but I know is 2 over 4 plus 2 over 4 is equal to r squared. So 2 over 4, 1/2 plus 1/2 is 1. So r is equal to 1. Boom, bang. Okay, so I have the cotangent. What I'm going to use is, I can see right now this is a 45, 45, 90 triangle, so theta is equal to pi over 4. But if I were to type this into my calculator to double check, I need to use the cosine ratio. So the ratio for cosine is x over r. So I need to use my x length, which is root 2 over 2, and my r length over 1, and that's going to equal theta. So where is cosine, what triangle gives me a cosine ratio of root 2 over 2? That's when theta is equal to pi over 4, right here, pi over 4. All right, let's do another one like that. Okay, so cotangent inverse of negative root 3. So I'm just setting up. We're going to get an angle in quadrant 1 or quadrant 2. And since the ratio is negative, it's going to be quadrant 2. Okay, so I have a ratio of x over y. So I am just going to go ahead and start labeling my side lengths. So x is going to equal negative root 3. The y I'm going to label as 1. Now I need to solve for my r. So r squared is equal to x squared plus y squared. So r squared is equal to negative root 3 squared plus 1 squared. R squared is equal to 3 plus 1. So r squared is equal to 4, and then we'll take the square root of both sides. So r is equal to 2. Okay. So remember, we don't use the tangent inverse to solve for cotangent. We use the cosine inverse. So cosine inverse of and the cosine ratio is made up of x over r. So I need to use the x length, which is negative root 3, over the r length, which is 2, equals theta. And I'm like, wait a second. Usually I see my triangle as a radius of 1. So I'm going to divide all sides by 2, and that will equal 1. And I see that the reference triangle is just a pi over 6 triangle, which means that this angle in the second quadrant here would be theta is equal to 5 pi over 6. So the cosine ratio that gives me negative root 3 over 2 would be 5 pi over 6. Okay, so for the calculator, last problem. We're going to solve with the calculator. So again, for cotangent, we're going to set this up as the cosine inverse of, okay, the ratio here is my x length over my y length. But when I set up my ratio, since I'm using cosine, I need to use the x length over the r length. So I do have to draw my triangle, solve for the 3 sides, because I need to figure out what the r length is going to be. Okay, so the ratio is negative. It's going to be in the second quadrant. I'm going to use the negative 1 as my x, and the y is going to be 3. So to find r, I use negative 1 squared plus 3 squared. So r squared is equal to 1 plus 9, which is 10. So r squared is equal to 10. So r is equal to root 10. Okay, root 10. So to set up my cosine ratio, I'm going to use negative 1 over the square root of 10. Okay, which gives me, do this in my calculator, go this way, cosine inverse of negative 1 over square root 10. 2 parentheses, 1 to close the root and 1 to close the ratio. And I get my angle is 1.89. So theta is equal to 1.89. That's in the second quadrant. All right, and that is it.